Hello everybody, welcome to Credit 9 Day 1. This starting thing is going to desmos.com. You're going to enter the class code fry8 and answer these questions while you work through that. Then we come to our first activity, which is suspension bridges. Some of the longest bridges in the world are suspended by cables that hang in parabolic arcs between towers. One of the most famous is the Golden Gate Bridge in San Francisco. So they have an approximation for a parabola that represents the cable. Actually, hanging cables follow a different formula, but I won't get into that. But this is an approximation of that hanging cable. And what you're going to do with this information from this graph is answer these questions here. So what is the approximate height from the bridge surface of the towers from which the cable is suspended? So I guess if the bridge surface is at 0, so how high is the tower, right? So that value there, that value there. What is the shortest distance from the cable to the bridge surface? So what is the shortest distance that the cable is from the bridge surface? And then it looks like it's going to be at that relative minimum. And for what interval is a suspension cable at least 75 feet above the bridge surface? So 75 feet is somewhere around here. So at what interval is it at least above that, right? So it would be over here and over here. So you can go ahead and answer those questions. Then you're going to watch the video on GeoGebra, manipulating the axes to see the parabola. Then we jump into this activity about the Tibetan Freedom Concert. And they ask you some questions about that just to make sure you understood what you read. So what factors could affect the number of tickets sold, and what could reduce the profit from the ticket sales. Okay, then we jump into this part, which is going to be our mathematical modeling part. So they give you this relationship that the number of tickets sold and the ticket price is approximated by this linear function. So the number of tickets sold is kind of based on the price. If it's too expensive, people aren't going to buy many tickets, but if it's cheaper, then we probably would sell about 4,000 tickets, right? If it was 0 cost, then we'd sell 4,000 tickets. Okay, and then they give me this relationship that the expenses for promoting the concert are these different values. So if you add them all together, that's the expense for putting on the concert. Okay, and then you're going to find a function that's used to predict the income for any ticket price. So the income for any ticket price is going to be the number of tickets sold, right, which they gave you up here was S, times the price of each ticket, right? So the number of tickets sold times the price of each ticket is S times X, which S depends on X, right? So what you want to do is substitute this in for S, using your parentheses, and then multiply it out, and then you get this sort of function that is I in terms of X. So you can do that over there. Then you're going to find a function that can be used to predict the profit for any ticket price X. So this is the profit in terms of X will be the income minus the expenses. So you have some function here that's the income, so it's going to be income, this in terms of X, minus all these expenses, right? If you add up all these, that's the expense. So then you're going to take those two functions and put them into GeoGebra and adjust your axes so you can see the parabola, and then you can go through and answer these questions. So how do you predict the income and profit change as the concert organizers consider ticket prices ranging from $1 to $20? So you can, look at, I don't know what the parabola looks like, something like that. So you can look at what is the value at $1, $2 on to 30, right? So the ticket price or the income. So if this is the income curve, you can look at what are the different prices at these points, right? So up to 20. So is there an income right there? And then there'll be also a profit curve, which you probably lose money if you give the tickets away for $0. So it's probably, something like this, that you actually lose money at 0, and then there's some break-even point where you actually the profit is actually 0, right? So I don't know where that is. You're going to have to figure it out when you put it into GeoGebra. Okay, so just more question. Yeah, this is the break-even point question right here that I just talked about. So where does the profit go above the 0? That's kind of like our x-intercept, right? Then you just have some more questions to answer on that, and then you have some questions to answer in your math notebook, and that's it for today.